Hi all, today we are going to discuss plate bearing test. Plate bearing test is a test that is used to check the capability of the subgrade soil or any other pavement layer to withstand the load that is transferred to it due to the traffic. This test is conducted by simply applying compressive stress over the desired layer and noting down the corresponding deflection. By varying the compressive stresses and finding out the corresponding deflections, we can study the behavior of the pavement layer by plotting stress versus deflection curve. During the test, the deflection is limited to 1.25 to 5 mm and hence the deformation occurred may be partly elastic and partly plastic. Originally, plate bearing test was used to determine the modulus of subgrade reaction of the cement concrete pavement. This test is applicable for both flexible and rigid pavements. Modulus of subgrade reaction, elastic modulus, and the pressure versus deflection behavior all can be studied from the results obtained from this test. Now let us discuss the procedure for conducting plate bearing test. For conducting plate bearing test, usually a mild steel plate of diameter 75 mm is used to transfer load to the desired pavement layer. For example, if you are going to conduct the test on the subgrade, first the subgrade layer has to be cleaned and leveled, and then the mild steel plate of 75 mm diameter should be placed over the subgrade, and then the load has to be transferred to the subgrade soil through the mild steel plate using a hydraulic jack. First, a seating pressure of about 0.07 kg per centimeter squared should be applied and released. After releasing the seating pressure, the dial gauge readings have to be set to 0 and a pressure that causes an average settlement of about 0.25 centimeter should be applied. Usually a minimum of 3 dial gauges which are placed at an angular distance of 120 degree should be used. The result should be the average of the readings that is obtained from the 3 dial gauges. The reading is taken once there is no perceptible change in the settlement or the rate of settlement is less than 0.025 mm per minute. The load is then increased further to cause a further increment of about 0.25 mm settlement and the corresponding deflection is noted. Likewise, the procedure is repeated until the desired deflection is attained. The observed readings are then used to plot pressure versus deflection curve. The graph can be used to predict the deflection for the required pressure or to predict the pressure for the required deflection. The modulus of subgrade reaction can be obtained from the formula given in the last point, which is K is equal to P by 0.125 kg per centimeter square per centimeter. Here K is nothing but the modulus of subgrade reaction and P is the pressure applied over the mild steel plate which is eventually transferred to the subgrade layer. Subgrade moisture correction. So there are two different corrections that has to be incorporated to the results obtained from the plate bearing test. One is subgrade moisture correction and the other one is plate size correction. So normally the plate bearing test has to be conducted on the soil at the worst moisture condition, that is at fully saturated condition. Then only we can get the lower limit of the strength of the subgrade. But actually it is not possible. In the site we cannot control the moisture content, right? So in the subgrade with the actual moisture content itself we will conduct the plate bearing test. So after obtaining the pressure values versus deflection values, we can plot the graph and find the modulus of subgrade reaction, and then we can correct the value to the worst moisture condition, that is fully saturated condition. So for that we have to obtain two different samples from the site, and one has to be fully saturated and the other can be at the natural moisture content itself, that is the site moisture content itself. So both the samples should be subjected to laboratory consolidation test, that is the pressure versus deflection graph that is obtained from the test then be plotted to find the behavior of both saturated and site moisture condition soil samples. The pressure required to produce a settlement of 0.125 centimeter is then used to compute the correction value. This value was determined at the time of plate load testing itself. The corrected modulus of subgrade reaction for the soaked condition can then be determined using the formula given below, that is Ks is equal to K into Ps by P, where Ks is the modulus of subgrade reaction at saturated condition and K is the modulus of subgrade reaction at natural moisture content condition, and Ps is the pressure required to produce 0.125 cm settlement in saturated condition, and P is the pressure required to produce 0.125 cm settlement in natural moisture content condition. Next one is the plate size correction. So normally the plate load test has to be conducted using the plate size of 75 mm diameter. But if we don't have 75 mm diameter mild steel plate, we can use a mild steel plate of diameter lesser than 75 centimeter. And then we can correct the result to 75 centimeter plate size diameter. So the corrected modulus of subgrade reaction for smaller plate size can be determined using the formula K is equal to K1 into A1 by A, where K1 is the modulus of subgrade reaction for smaller plate size and K is the modulus of subgrade reaction and K is the modulus of subgrade reaction for 75 centimeter plate size, and A1 is the plate size that is used by us, that is a smaller plate size, and A is the 75 centimeter plate size, 75 centimeter diameter plate size. So incorporating these two conditions when necessary, we can find out the modulus of subgrade reaction from the plate load test. Thank you.